Standard two-dimensional maps trick our brains into thinking the United States and Russia sit on opposite sides of the world. But if you look down from a top-down polar projection, you see they are practically touching. The landmasses of North America and Asia are separated by a shockingly small gap. It's a mere 55 miles of water at the Bering Strait. Right in the middle of that gap sit two small landmasses, the Diomede Islands. The larger one belongs to Russia, and the smaller one is United States territory. The distance between these specific islands is just 2.4 miles. It's a harsh, jagged environment, choked by heavy sea ice most of the year. But that proximity means you can literally stand on the rocky shore of Little Diomede, look out across a narrow channel, and see a rival superpower staring straight back. If the physical gap between these continents is small enough to see across, what is preventing us from connecting them? Why aren't you driving a car straight from New York to Paris? This animated cross-section shows the bathymetry, the underwater topography of the Bering Strait. Spanning the ocean here is highly feasible because the water is incredibly shallow, bottoming out at just 160 feet. Because it's so shallow, engineers can easily anchor structural foundations to the seafloor, and they wouldn't have to build a single massive span. The Diomede Islands act as natural load-bearing stepping stones, breaking the project into 3 manageable segments. We also have decades of proof that building intercontinental subsea transit works. The Eurotunnel safely carries heavy rail traffic deep beneath the English Channel every day. And we know how to do it in extreme climates. Japan's Seikon Tunnel operates deep underwater in a freezing, earthquake-prone zone, closely mirroring the exact conditions up north. Between the shallow seafloor and our existing successes with subsea tunnels, the construction of the bridge itself falls well within the limits of modern industrial capacity. This continental map shows where the real barrier lies. You have to pull back from the strait itself and look at the macro geography of Alaska and Siberia. There is an absolute infrastructure vacuum. The nearest paved road network in Alaska ends hundreds of miles away. On the Russian side, the closest major rail line stops well over 1,000 miles from the coast. To even reach the site of the bridge, crews would have to carve a brand new heavy-duty highway and rail corridor through thousands of miles of untouched mountainous wilderness. This cross-section reveals another severe problem: permafrost. The ground in these regions is a thick layer of rock, soil, and ice that remains permanently frozen. It's solid, but incredibly sensitive. Building heavy infrastructure generates heat. When that heat transfers down, the ice beneath melts. The foundation liquefies into a swamp, and the road on the surface simply buckles and caves in. Add in the brutal reality of the Siberian winter, plunging temperatures, violent ice storms, and months of total darkness, and maintaining that road network year-round becomes nearly impossible. The effort, time, and cost of these thousands of miles of approach roads would likely eclipse the construction of the bridge itself. Connecting these isolated coasts to civilization is the real logistical obstacle. Assuming you could engineer those roads, you are left with a multi-trillion-dollar price tag. To justify that expense, this route would need to move an enormous amount of highly profitable freight. But this theoretical rail line would be competing against the reigning king of global trade, maritime cargo shipping. Massive container vessels move goods across the open ocean at a fraction of the cost per ton. A hyper-expensive intercontinental train simply cannot offer freight rates low enough to pull that volume away from the sea. Even if the economics made sense, the geography sits on an active fault line. The Cold War border here was historically known as the Ice Curtain, and that tension never completely thawed. A project of this magnitude requires deep, generational trust. Sharing critical infrastructure, opening borders, and jointly managing a multi-trillion-dollar asset is a non-starter in a climate of active diplomatic hostility. The unconnected Bering Strait is not a failure of human engineering. We have the technology to cross the water. The gap remains empty because it stands as a stark physical monument to the absolute limits of economics and geopolitics.